Okay, welcome to this physical science session. We're going to be going over part of lesson 4. It's going to be 4.1, the second reading, atoms and molecules. So this is a lesson that doesn't have any practice problems to go over, and there is a review on your student portal, a review video that goes over most of this section. So I don't want to repeat all that. There is just one thing I'm going to focus on, and that's going to be the structure of an atom. So just to review, we've got protons and neutrons in the middle in this little ball of particles that we call the nucleus, and then you have electrons around the outside in different levels that we call shells. The number of protons in the middle is the atomic number, and that determines what element it is. So that's really important to know. So if we could count up all these protons, we would know what element we're looking at. Okay, I've got a model of an element here. Which one is it? I can't really count those protons because there's neutrons in the way there. If the protons are the blue ones, I can't see them all. So another thing to keep in mind is that the number of electrons in a neutral atom that hasn't bonded with anything else, the number of electrons is equal to the number of protons. So we can count the number of electrons here. Okay, this atom has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18. This atom has 18 electrons. That means it should also have 18 protons. Okay, so knowing that it has 18 protons, we can look at the periodic table. Oops. We could look at the periodic table and figure out that that is argon. So we would just look at the periodic table, find number 18, and that would be argon. Now, the electrons fill in the shells around the nucleus in a specific way, and this is really important. The valence electrons are the electrons in the outer electron shell. The other ones are not valence electrons. They're just random electrons, and they don't really have as much importance. The valence electrons are the ones on the outside, so they can interact with other things. The arrangement of the electrons around the nucleus is very important for 3 reasons. Like we just said, only the electrons in the outside shell, those valence electrons, can interact with other atoms. So it's important to know, which ones are valence electrons, how many there are. The structure of an atom determines how easy it is to take an electron away. So basically, the farther away the electron is from the nucleus, the easier it is to remove from the atom. And the number of valence electrons in the outer shell completely controls chemical reactions. It will decide what other atoms this atom can interact with and how many of them it'll interact with. The whole goal of atoms, the whole reason that chemical reactions happen, is that atoms want to fill up their outer shells. Okay, that's the entire goal. They want those shells to be completely full, to have the maximum number of electrons. So it's important for us to figure out how many electrons could be in an outer shell so that we know how close atoms are to attaining that goal of filling up their outer shell. So the way atoms are structured is you've got your first level, and that first level, that first electron shell, can only hold up to 2 electrons. So if you have 2 electrons in it, it's full. It cannot hold any more. So to add more electrons, we would have to add another shell. So the second level can hold up to 8 electrons. And once that's full, we have to add a third shell. And that third level, as far as we're concerned, can hold 8 electrons. Okay, so technically that's not true. You can get more, but that gets into really complicated stuff that we don't worry about in this class. So just to make things simpler, just think of it as it needs 8 electrons, just like the second shell. So let's look at actual models of specific elements. If you have hydrogen, it's got 1 proton in the middle, 1 electron going around that first shell. If you want to make helium, you have to add a proton and an electron and some neutrons, and you have 2. So now that shell is full, so we have to add another one. And if you notice on the periodic table, this top row has hydrogen, and then all the way on the right it has helium. And then to get to element number 3, we have to jump down another row. So lithium is in the next row on the periodic table. And the reason for that is when we get to lithium and we want to have 3 electrons, we have to add another shell. So because we added another shell, we jump down another row on the periodic table. All right, so that's element number 3. And then we have 4, 5, 6, 7, 8, 9, 10. We just keep adding protons and electrons. But now number 10, neon, is full. So you've got its inner shell has 2, it's full. Its second shell has 8, so it's full. So if we want to get down to the next element, which is going to be 11, we're going to have to add another shell. And that means we also have to jump down another row on the periodic table. So sodium is down another row because we add another shell. Now it's important to realize sodium has 11 electrons. Sorry about that. It has 11 electrons, but it's only got 1 valence electron. So the ones that are important are the ones in the outer shell. So neon has 10 electrons total. 8 of them are in its outer shell. That outer shell is full. So sodium has more total electrons, but it only has 1 valence electron, and that's the one that we care about. So if we look at the periodic table, the way that it's set up is so that you get a pattern where everything in this first column, which is called group 1, has 1 valence electron. Everything in the second column, group 2, has 2 valence electrons. Then we skip over these middle ones. These are the transition metals. They have some crazy rules. We're just going to ignore those. You wouldn't get into those in an introductory chemistry class like this. So we skip over those. We go to the next column that has 3 valence electrons and then 4. The next one is 5. The next one is 6. The next one is 7. And that last column has 8. Those are completely full. All right, so putting it all together, this is just a shot of a chunk of the periodic table. Mostly this is all that you'll be using for class when we're talking about actually using formulas and equations. So you may want to just kind of screenshot this or just make notes that each column has a different number of valence electrons, and we just kind of skip over the transition metals in the middle. Okay, so that's actually all I wanted to talk about for this section. If you do have any other questions about it, definitely contact an instructor.